Viitorul e al tău, noi punem temelia. UTCB, construim pentru România. UTCB, Universitatea de Construcții București.
Hello everyone, my name is Daisuke Takeda. I'm a consultant specializing in asset management of infrastructure and buildings and work for an engineering and consulting firm ISS. Today I'm going to talk about the bridge classification, which already Mr. Wakahara has referred to. So I'm going to explain a bit detailedly about the bridge classification, which is one of the key techniques of our R&D project that is for the management of the bridge maintenance. Mr. Wakahara and Mr. Rita and I work for the same team, so some of the sheet is the same as their sheet, presentation sheet. So to begin with, let me explain about the practical fields that the new system we are developing is targeting Tottori Prefecture. Our R&D project, SIP, Strategic Innovation Program, is emphasizing that the R&D should finally implement it to the real world and used practically, not just R&D in laboratory. So Tottori is local countryside, and the place is famous for sand dunes, Mount Daisen, and good food such as crowds, pears, chickens, or beefs. And 500 kilometers distance from Tokyo. I guess this is about the distance between Bucharest to Istanbul. The prefecture's population is smallest among all the areas in Japan, and moreover, the population is declining in these 25 years. Population decline means tax income decrease, and even in this situation, the infrastructure is getting old. Let's see the bridge management situation in Tottori. The Tottori government is managing 2022 bridges, most of which are constructed in the period from 1960s to 1990s. That means most of the bridges will be more than 50 years old in 2030s, and they will come soon, actually, just like me. As construction was done in short period, in 60s and 70s, 1890s, the deterioration will occur in short period. The bridges must be maintained well, not to deteriorate and lose their function. But the budget is limited and local human resources are getting shorter. Also, some bridges are difficult to do repair work if the bridge has heavy traffic and the traffic cannot be interrupted by the repair work. This is the situation, and it's not only in Tottori, but the same in local areas all over Japan, or maybe world. I'm going to show the bridges in Tottori by each structure type. So they have 104 steel bridges, like these. This is the shape of Tottori. The 520 bridges are precast concrete bridges, and 546 bridges are RC bridges. And box culverts, 552 structures. I don't know whether box culverts are categorized as bridge in Romania, but we do in Japan. Let me add one thing. Those are the bridges that are managed by Tottori government, and there are more bridges in this region because many other bridges are managed by local municipalities. And again, their budgets are limited and more limited than Tottori Prefecture. So I'm going to explain the classification system we are developing, but I guess many audiences today are wondering, what? Bridge classification? Isn't it normal strategy? Many municipalities are practicing it already, isn't it? Yes, that is true. The same in Japan. Many governments have their classification already. But the issue is those classification systems are not connected to political or governance aspect. And because of that, maintenance is not done, let's say, strategically. And to address this situation, the classification that is set using scientific evidence is the one we are developing. And with this system, the government can achieve evidence-based policy making, EBPM. This is maintenance cost estimated in Tottori until 2073, 100 billion yen from 2023 to 2073. It's about 4 billion day, and this estimate is made based on current classification system, and we are trying to make the budgets lower by new classification system. So this is current plan, and we are going to trying to change. So to set classification system, firstly we evaluate the bridges. To do this, we are developing the system which we call public asset platform, this one. And the platform accumulates, like this layer, information that affects the value of bridges in a geographically integrated form. As we choose the information or data elements, we focus in two aspects. The first aspect is normal occasion, and the second one is disaster occasion. Also, the form of each element is differently plotted, and road network, which the data is plotted as line, facility location. So, I don't know, this is my lines, yeah, road network layer. The facility location layer plotted in the point shape, and regional information such as regulation, population, and land price or seismic property, which those data is plotted an aerial form, and all the data is accumulated in one platform. So this is a platform. This is the tool we are developing to classify the bridges. And this is a diagram, concept diagram that shows how our evaluation process works. We have data elements in the platform I just showed, and the data elements will be the factors to calculate the value of each bridges. In the calculation, the effect of each data element, like the location of the facilities or the land price, each element will be used differently in calculation. So in the calculation, the effect of each data element will be different, and that will be decided along with policy themes. Like if the government's focus area is, like, say, economy or sightseeing or regional resilience for disasters, that kind of elements will be highly evaluated in the calculation. By this process, we will evaluate the bridges. And the calculation will be done with the program PAS, just Dr. Fujita have referred to. PAS is Public Asset Simulator, which can calculate theoretical traffic amount. This program uses information of road network, the regional population and facility location, and calculates the amount of theoretical traffic that goes to certain facility on a particular point of a road or bridge. Also, other related information can be input to past program. So this demographics input to past program, and then traffic is calculated. So let me say it again. The theoretical traffic is that the traffic goes to a certain facility which the programmer chose, and like point of road or bridges, the traffic for the point of road will be calculated. And again, this is facility accessibility analysis result. The characteristics, seismic period at each bridge site. Those data has been input to the PAS. And using the PAS path, we have resulted one of this classification model currently at the concept, and I will explain the concept of each class. Yes. Oh, sorry. So this map shows the red point is the bridges with class A, and the green color and blue color shows B and C and D. This is plotted to the maps. And class A bridges are the top 20% rank bridges, which covers 80% of traffic in Tottori. This shows ranking the bridges by the traffic amount. And very small number of bridges have high traffic level. So this is the shape this kind of effect shows. And on the other hand, class D, Japanese bridges, the theoretical traffic is 0. So it's theoretical traffic. So sometimes some bridges have 0 traffic theoretically. And the bridges not in use, I can say. Class B, the bridges that traffic from white region uses, and the bridges that the traffic in particular region uses is in this area. So we set some political themes such as the region that supports elder people's life, and along with that theme, we chose some facilities as destination of the traffic and calculated the traffic amount. So this is a result of calculation of the traffic. After setting the classification, the next step is to set the maintenance level for each class. And then we can calculate the maintenance cost that is needed and simulate the budget allocation in long term. After this simulation, the classification will be considered as the circle shows. So simulating the classes and budget allocation, and again we see the whether the classes are right or not. This circle is for the management, and always the circle must be executed together with maintenance circle like this. If I simply say the maintenance cycle consists of inspection, evaluation, design, repair, and inspection again, and so on. Actually, we developing public asset platform I referred already, and also the infrastructure bit platform. And so both platform, with those both platform, we are making the database, and which today I'm not talking about this database, but two platforms and database will work how to maintain and which bridges must be which class and how to maintain. We can decide, and we can decide the budget. So let me wrap up my presentation by showing our R&D's goal again. We are developing the process to classify the bridges. The local government manages and set the maintenance level of each classification that enables executing adequate maintenance with a limited budget. To do this, we maintain resilient infrastructure sustainably that will secure everyone's life in the region regardless of potential risk, and to practice a smart system for the creation and maintenance of infrastructure. Thank you very much.
UTCB, viitorul e al tău, noi punem temelia. UTCB, construim